Hey, good day. This is Isaac from the Dedicated Server Handbook, and today we're going to look at a practical introduction to IPv6. Now, there are a lot of IPv6 tutorials out there on the internet, but most of the ones that I found when I was first learning this were really suited for advanced users. And even for advanced users, it was really hard to find the basics. So in this tutorial, I hope to cover the basics to let anyone who has a dedicated server with a static IPv4 address make their server IPv6 enabled. Let's get started. So a bit of background on IPv6. It's a replacement for IPv4 because IPv4 address space is running out. And as of February 2011, the top-level internet registry called the IANA has already allocated all of the IPv4 address spaces to the local registries. IPv6 was proposed in 1999, but despite that, it's still not significantly used. Only 10% of the internet today is really IPv6 ready. Our website, www.thededicatedserverhandbook.com, is already dual stack enabled, meaning that it runs both on IPv4 and IPv6. This means that anyone using IPv6 at home can view our website natively over IPv6. IPv6 is fully supported by the Webmin core, which means that Webmin itself could listen on IPv6, but not all modules have support yet for IPv6. For example, the bind DNS server module, you can manually add IPv6 records, but there's no record type for IPv6 addresses. They have to be added manually in the edit zone file. Any website with a dedicated IPv4 address can get an IPv6 address in minutes. And actually, you don't even get one address, but you get an entire 64 subnet. An entire 64 subnet, just to put things in proportion, is if you take all IPv4 address space and you multiply that by itself, that's how many addresses you can get if you just have one IPv4 address. Okay, some basic terms for IPv6. : 1 is localhost. It's the same as 127.0.0.1. The full broadcast address, known as 0.0.0.0/0 in IPv4, is referred to : or sometimes for people who want to be purists, they refer to it as 0:0. Now, don't get lost with all these colons. I'm going to explain that really soon, how all those work. There's a special link local prefix called FE80::, and the : there just means that there could be anything after that. That's called a link local prefix. It's kind of similar to the private address spaces in IPv4, but it's not the same. The important difference is that FE80 represents a single physical network connection, which means that any devices connected, for example, in your home network by your switch, can all speak to each other over the FE80. But FE80 will not span over routers, meaning that you can't span these over the internet. The current global prefix is 2000::/3, or subnet with 3 bits. That's the currently allocated global prefix. That actually means that less than 10% of the entire IPv6 address space has currently been allocated, meaning there's still a ton of room for anything that might crop up in the future. Public machines get both a 2000::/ address and an FE80::/ address. Why? Well, the 2000 address is how they talk to machines all over the internet, and FE80 is used just to talk to machines local to them on the same network. Address formatting. A typical address might look like this. I'm not even going to try to say the whole thing. It's pretty long. Luckily, IPv6 has two really great shortening tools that can be used. First of all, leading zeros can be eliminated, making that big address into this smaller address. And it gets even better. Lots of zeros can be replaced by colon, but only once in the entire address, meaning that our original address has now turned into this, which is still pretty long, but it's a lot shorter. Now, if you think back to the localhost address and to the 0.0.0.0 address, now you'll understand why they're colon, 1 and colon. Some ISPs already provide native IPv6 addresses. For example, all of our virtual dedicated server plans come with their own IPv6 IP address. But even if you don't get your own IPv6 address from your ISP, you can still use some services to connect anyone to the IPv6 network. The only restriction is you need to have an IPv4 address. In the following example, we're going to use Hurricane Electric as a tunnel broker. And I'd like to just take a moment to publicly go on the record and say thank you to Hurricane Electric and all the other online tunnel brokers for the incredible work that they've been doing for IPv6. All set? Let's do a live example now. All right, let's get started with a live example. Here we have a stock webmin installation off of one of our VPS servers. This is the same configuration that you could expect to get your server from either us or from your local hosting provider. Although we provide IPv6 addresses on our plans, not every service provider does that yet. So for the sake of example, I've gone and disabled the IPv6 addressing on this machine before starting this tutorial. That means that this machine is only connected via the IPv4 network. The first thing that we're going to do is we're going to add IPv6 support to webmin. Now, webmin comes configured out of the box being IPv6 ready, but there's an additional pro module that we have to install first. So we're going to go and install the software package that we need, called Socket 6. Now we're going to go to webmin configuration. We're going to click on ports and addresses, and we're going to enable IPv6. That's all the basic configuration that webmin needs. IPv6 has now been enabled in the webmin core. However, before we go any further, we need an IPv6 address to use. To get our IPv6 address, we're going to go to Hurricane Electric's IPv6 tunnel service, and using our IPv4 address, which we can see here, we're going to get an IPv6 address. First, we need to sign up for Hurricane Electric. I'll leave that as your homework, but it's really, really easy. Once you've logged in, you click on Create Regular Tunnel. Now, here you'll need to provide your IPv4 endpoint, your side. That's the IPv4 address of your server. If you're connecting through an IPv4 only address, this form will automatically fill in your home IPv4 address above. Let's fill in our server's IPv4 address. The service will then check the validity of our IPv4 address and ensure that it can be used as a potential tunnel endpoint. Next, we select an endpoint that's close to us geographically to get the highest possible speed. That's it. Hurricane Electric has gone and created a tunnel for us. Now, to quickly set this up on our server, we're going to go to Example Configurations and select Linux NetTools. Then all we need to do is copy and paste these commands into a command window. We could do this as a one-time process in Webmin through the command shell, but I'd rather make sure that this comes up every single time we boot. One last thing before we go back to Webmin is that you can use the same example commands to connect yourself at home. As you can see, most operating systems have example code that can be used, including Apple, Linux, BSD, and Windows. All right, let's go back to Webmin and set up our IPv6 address. So we're going to go to System, Boot Up and Shutdown. We're going to go click on the existing networking action. Networking is used to start up all the networking devices on the system. We're just going to add our code to the end. To do this, we're going to add a post start script. And now we're going to paste everything that we got from Hurricane Electric right into here. And we're going to end that with an end script. And we're going to save. Now we're going to restart the networking service in order to bring up our new IPv6 address. And that's it. If everything's gone well, we now have IPv6 enabled on our system. In order to test that, we're going to go to Others, Command Shell, and we're going to execute ifconfig to see all of our addresses. As you can see, we have our new addresses set up. This is our IPv6 address. To test it, let's try pinging this from a remote site. There are plenty of freely available ping tools on the internet. Let's just take one by random. IPv6 ping. We're going to paste our address in here and click ping. As you can see, we've got a response. Now let's test it the other way. From the command shell, let's try pinging Google. Ping 6 c4 ipv6.google.com. Now, we need to write that c4 argument because otherwise in Linux, ping will keep pinging forever and we'll never see the output. Let's click execute command. And there you go. We've got responses from Google. For the last test, let's try to access Webmin over IPv6. We're going to open a new tab and connect to HTTPS, our new IP address, which we put in square brackets for IPv6, on port 10,000. And if all goes well, we'll get to our login screen. So that's it. As you can see, it's really easy to get yourself up and running in IPv6. I hope you've enjoyed this IPv6 tutorial, and I hope that you're able to use it to add your website to the IPv6 world as soon as you can. Once again, this is Isaac from the DedicatedServerHandbook.com, wishing you a great day. Bye-bye.